Would you say that the Galileo Project is the single biggest organization studying UAP right now
Well,
worldwide?
it's definitely the best funded because we are receiving funding for all these observatories we're building. We are
Yeah.
collecting more data than anyone.
Yeah.
Already, we have a few million objects that we looked at from one site in Massachusetts. But what I'm saying is we will have altogether 4 of them. So every year we'll have a few million, and
Wow.
so eventually it will be the biggest data set ever of objects near Earth, and also the one that is studied with machine learning in a systematic way. Then part of the data I hope to share with the public so they can look into it. And I think it will be very exciting once we have huge amounts of data coming along the way. You see, other organizations either are relying on anecdotal reports or a few days where they went somewhere and looked around, or things that were collected over the decades. But I think collecting new data has the power that you can have much better quality, and you can check it. If you see something unusual at a particular site, you can look there for an extended period of time and try to figure it out. And so if you look at past reports from decades ago, you have no way of visiting those events again because they were so long ago. So in that sense, we are very different. I'm not aware of another project that is scientifically oriented for a very long-term data assembly like we are. We are basically just like any other astronomical, research observatory, except we will build multiple observatories for the same goal.
Last question here, Dr. Loeb. If you had unlimited budget and resources, how would you approach this?
Yeah. So that was the basis for my bet with Elon Musk, which, I think that we should invest billions of dollars in that kind of research. And I have very clear ideas about what needs to be done. Obviously, the more observatories we can spread around the globe, the better. If we have 100, then we'll have, we could have.
How big are these observatories, by the way? Like when you say that, I imagine something out of like James Bond, just this huge thing.
They're not so big. They are,
okay.
About 10 meters by 10 meters that have multiple instruments spread around. But they do cost $1 to $2 million each if you want triangulation. So
sure.
So if there were hundreds of those, that would actually give us a lot of data on hundreds of millions of objects every year that we can monitor and see what's going on. And the more sites we visit, the better is the knowledge that we have of what might be anomalous. And but aside from that, I developed a concept for a space telescope that would search for interstellar objects close to the sun. The sun is the lamppost that illuminates the darkness of space. So it's easier to check for your keys under the lamppost. So I calculated that every 5 hours, there is a new interstellar object, roughly the size of a person, that enters the orbit of Mercury around the sun, which is about 3 times closer to the sun than the Earth is. And that is close enough so that every object that gets there is heated to 600 degrees Kelvin above absolute zero. And in principle, some objects might evaporate, and then you could study the composition without even landing on them or bringing them to Earth. Because you can look at the evaporated gases and figure out their composition. And so there is a possibility of building a space telescope that would search for such interstellar objects within the orbit of the Earth around the sun. At every given time, there are 1 million such objects. Right now, it's just that the Earth collides with one of them once per decade. So it's rare to see a meteor. But if we had a powerful telescope that can search for these meter-sized interstellar objects, we might find technological debris among the rocks that came into the solar system from outside, and I think we should do that. So if I had the billions of dollars, I would definitely fund the space telescope targeting all the objects within the orbit of the Earth around the sun.